Okay, good afternoon. Hello, everyone. My name is Robin. I work for Confluent. You may have heard of Confluent. They're one of the companies who contribute to the open source Apache Kafka project. We have our own Apache Kafka distribution called Confluent Platform. So I want to tell you a bunch of good things about how you can use Apache Kafka Connect, but I want you to tell me two things. The first is, am I speaking too fast? Not right now. I get more and more excited, so if I get too fast, please start waving at me, okay? Because sorry, I don't speak French, so we have to do it in English, but if I get too fast, please just start waving. The second thing is, who's using Apache Kafka today? Okay, about a third of you. Is anyone using Kafka Connect today? One, maybe, thinking about it. Okay, so hopefully you're here, not just because it's like, well, it's one or two, and it's kind of, it looks all right. But you want to know about Kafka Connect, so that's what I'm going to tell you all about. So Kafka Connect is part of Apache Kafka. You've probably heard of Kafka. It's kind of everyone's talking about it for the last few years. And Kafka Connect is part of the Apache Kafka API. So if you're using Apache Kafka, you have Apache Kafka Connect. And what Kafka Connect is a way of doing streaming integration between systems upstream from Kafka into Kafka, and from Kafka out to other systems. And Kafka Connect is fantastic because it avoids you having to reinvent the wheel a lot of times, and lets you just build your applications as you want to do and spend your time writing your application rather than writing kind of frameworks and kind of bits to do the integration. That's what Kafka Connect does for you. So you can use it to get data from systems upstream. Got data in databases and message queues and flat files and JMS and who knows what. You've got data in thousands of different systems. You can stream it into Kafka using Kafka Connect. You can take data from Kafka and push it down to numerous other systems, out to databases, out to the same database or different databases, or to HDFS or BigQuery or S3 or wherever you want to put your data. And the beautiful thing about Kafka Connect is it's just configuration files. So it means you can actually build end-to-end pipelines using Kafka, integrating different systems, but just with a bit of JSON. So this being Voxed, I suspect a lot of people here are kind of hardcore Java programmers, and that's fantastic. I'm like a bit of a charlatan. I'm not actually a Java coder, but I can write a mean bit of configuration, and that's why Kafka Connect's kind of interesting to me, but it should be to you as well. Because it means the tricky thing of how do I get data from this place into Kafka, or from Kafka to this place, you don't have to write that. You can. I mean, it's fun solving problems that someone else has solved already, but it's not a great use of your time. So Kafka Connect does that for you. So you can use it to build end-to-end pipelines, or just data from Kafka to push it down to here, but it means that you're not having to write that piece yourself. So people use Kafka Connect in different ways. Some people start off with Apache Kafka simply as this idea of a message bus, and we're just going to shunt data from here, integration pipeline over there, and that's fine. Apache Kafka is fantastic for doing that, and Kafka Connect is the piece that lets you do it. Got data sat in this expensive transactional database over here. We're going to stream it, we're going to offload it into Kafka, and we're going to push it into, to where have we got? Into S3. But we also have that same data. We say, well, let's also go and put it into HDFS. Because we have two different teams who want the same data, or we're using S3, but we also want like an on-premises replica, or for whatever reason, you can have the same data pushed out to different places. Not everyone realizes that Kafka persists data. When you read a message out of Kafka, it's still there until you expire it out, and you say, well, it's been 2 weeks, or we've got like 10 gigabytes, so we start to age out the old stuff. But you can also persist data forever. You can keep it in Kafka forever if you want to, depending on the business case. But the point is, as the data comes into Kafka, you can use that multiple times. You can push it up to S3, you can push it to HDFS, you can consume it in your application, someone else can consume it. When it's read from Kafka, it's not deleted. So we can use the data multiple times to build out these pipelines of different types. We can use Kafka Connect to take data that applications writing into our broker and push it down to a data store. So instead of our application doing our application thing and say, right, now I'm also going to write a bunch of application code which is going to connect to Elasticsearch and work out like, if Elasticsearch isn't offline, then I'll have to buffer that data myself, and when it comes back online, then I'll push it down, and then we need to scale out, and how do I manage all of that kind of stuff? and something breaks, and how do I handle restarts and schemas, all that kind of stuff, Kafka Connect does that. So Kafka Connect is this framework that is distributed, it's scalable, and it's smart. It manages what's the schema of the data. Where did I get to before something went bang, and I can restart. All of those tricky things that you start off on day one, it's like, oh, well, we'll just do a push out to this data store. And on day two, it's like, oh, the data store went offline. I guess we need some retry logic. And then like, oh, we need to scale out. And like, oh, crap, this is a bit more complicated than we thought. And then you get really, really clever, and you spend a month building a solution that is now entirely bespoke to your system and that data store. And then someone says, well, we also need it over there. And can you pull data in from over there? And by the way, this new person's joined the team. Can you bring them up to speed on your bespoke solution? It's like, well, there's a framework that does that. It's called Kafka Connect, and everyone knows it, hopefully, after this. So Kafka Connect gives you this ability to push data down to data stores from a Kafka topic, to pull data in from places as well. So we can use Kafka Connect as a way of bridging from existing systems into new ones. We've got an existing system, we've got the big, scary, naughty monolith sat on top of a database. We've got it doing all its monolithic things, writing down into a database as our state star. And we say, well, when something happens in that original application that we want to start chipping away bits of functionality into our nice new shiny services, we want to know about that. Well, we can't start building hooks into that, but I suppose we could. But much neater is we can say, well, the database is our source of events. We can use Kafka Connect to hook up to the database, to the transaction log, and when something changes in the database, as a result of our original application doing something, we can capture it. An insert, an update, a delete, any change in that database is an event. And we can capture that using Kafka Connect and push it into a Kafka topic. And from there, our application can subscribe to that Kafka topic and can use it. So those are some of the reasons, some of the ways in which people use Kafka Connect. But anytime you've got data somewhere that you're wanting to pull into Kafka, anytime you've got data in Kafka that you're wanting to push somewhere else, you should be instinctively reaching for Kafka Connect. And then maybe find, like, here's the edge case, like, here's the reason I'm going to write it myself. But a lot of people end up writing a bit of code that I'm going to pull the database and pull this into a Kafka topic so that I can then use the data and do something useful. That bit, before you get to the useful thing, that's what Kafka Connect does. So I want to show you how easy it is to use and what it can actually do. So let me mirror my screen. All of this code is on GitHub. So I'll share the links afterwards. I'll tweet them if you do the Twitters. So you can actually try it out for yourself. So what we've got here, is that big enough at the back? If I do this, can you see the text? Are you still awake? Yeah? Good stuff. So we've got MySQL. It's a relational database. It's any relational database. I'm using MySQL just because I am, but it could be any other relational database. And in this database, we've got tables, because that's what you do with databases. And we've got a table called orders. So you can probably guess what's in the orders table. It's got order data. It's got order IDs and who placed the order and what did they buy and what was the value and where do they live. Stuff about orders in a database. This is not revolutionary. We've got an application that's writing data to that database. Okay, it could be something, it could be a third party, it could be our own application. It's something writing to the database. In my case, it's a data generator. So we're going to run that. And when we go back to the database, and we keep running that query, and the data's changing, because there's new data being written to the database. And what I'm going to do now is run this. And what that's just going to do is just going to sit there. It's just going to pull the database and just show us the fact that new data is arriving. We've got a create timestamp on there, which is UTC, so we're a couple of hours behind. So 12:39, 2:39, new data being created all the time. What I'm going to do now, in a new screen, is I'm going to create our connector. So let me paste that and then talk about it. So what we've got up here, let me show you on here because it's clearer, is we're saying I'm going to send some configuration to the REST endpoint. Kafka Connect you configure using REST. And we say, here's our connector class. Here's what we're going to connect to. We're going to connect to MySQL. So with Kafka Connect, you simply give it configuration. Which kind of connection is it? Well, this one's a MySQL one. It could be a JMS one or a flat file. This is MySQL. OK, it's MySQL, so how do we connect to it? Well, that's how we connect to it. And then this is the particular table we want from it, and a bit of other config and stuff down the bottom. But we run that, and it says, OK, I've created it. And we say, well, have you? Let's just double check, because this is a live demo, and things like to break in live demos. So we run that, which goes against the REST API, and it says, what connectors have you got, and what's the status? It says, well, I've got a connector. It's a source connector. It's called that, and it's running, which is marvelous news, because it means hopefully when we do the next bit, we'll actually see some data. So let's go and have a look at the data. Over here, this is just polling the Kafka topic, or it's consuming from the Kafka topic, rather. So this is showing us a continuous stream. So if I switch my windows to something useful, like this, on the right-hand side, we've got Kafka. On the left-hand side, we've got MySQL. So this is our application that's writing to a database. This is just a database with data arriving. This is a Kafka topic showing basically a near real-time feed of that data. So it was a full snapshot of what was in the database, plus every single subsequent change. And we're talking about not only inserts, but any updates and any deletes as well. So a full copy of all the events happening in the database in a Kafka topic, which is kind of useful, because we can use that data in the Kafka topic, which is a copy of what's in the database, and we can use that, we can shove it down to another data store, which we're going to do in a moment. 2 data stores, because that's twice as good. But we can also use that data to drive our applications. We've got a service that wants to know about when someone creates an order. Well, we could go to the original application and say, when someone creates an order and you write it to the database, can you tell me about it as well? Well, that's kind of a bit icky. We could start polling the database ourselves directly. Well, that's also a bit crappy. Or we could simply say, when something changes in that application, let's generate an event out of the database, and now anyone who wants to know about that order, the full payload is available. That's the whole point of an event. It's a notification, something happened, and it states, here's what happened. So we've got that data in a Kafka topic from running one configuration file. So what we can do now is we can actually push the data down elsewhere. So I'm going to send it to a couple of places. I'm going to send it over to Elasticsearch. So we've got the data about orders. We want to do some search on it, or we want to do some real-time analytics. So we say, well, let's go and put it into Elasticsearch. Again, we've got the connector class. We're using the Elasticsearch sync because we want to sync the data to Elasticsearch. How do we connect to Elasticsearch? Well, here's the connection URL. Which topic do we want? It's that topic. It's kind of fairly self-evident how we do it. So we run that, and it says it's been created. And then we're going to run another one, and this is going to send it to Neo4j. So one of the reasons why you would want to put data into Kafka to then route to other places is you can now start to use the most appropriate tool for the job you're trying to do. Rather than let's shove it into this one generic box that does most things quite well, but none of them particularly well, we can say we can use the best technology for the job at hand. I want to do some search indexing, I'll use Elasticsearch. I want to do some graph analysis, I'll put it into a graph database, I'll put it into something like Neo4j. But it's the same stream of data in near real-time replica from the database. We're not connecting each of these things together with bits of string and one thing changes and the whole thing goes bang. We're saying we've got the stream of events in Kafka. We can route it to here, here, and here. If one of these things we want to change or goes offline, the others aren't impacted. So we've got the data flowing between them all. If we run this, it says they're all running. We've now got 2 syncs. We've got one for Elasticsearch. We've got one for Neo4j. And all of them are running. The demo gods are smiling on me indeed. So what we're going to do now is actually have a look at this data. So whilst I open up Kibana and Neo4j, we can actually just poll the Elasticsearch REST API. So we can say, show me the order information. So let's put that on the right-hand side. On the left-hand side, we've still got the database, still got new data arriving. So in the database, order ID 454, 457, and so on. That's this one here. In Elasticsearch, if we keep polling it, 465, this one here, 465, 468. So it's basically, there we go, 471. It's exactly as it is in the database, streamed into Kafka, and now, in this case, in Elasticsearch. So we could have an application deciding to use Elasticsearch for its state star. We can now use Kibana, on top of Elasticsearch to give us a real-time visualization of the data. We can start noodling around it, we can start inspecting it, we can start analyzing it and digging into it, doing all the kind of good stuff that Kibana and Elasticsearch are fantastic at. We can also go and use a graph database and start poking around the data that way. We can say, well, let's look at the data from a different slant. Instead of like a kind of a rows and columns idea of data, let's actually define entities and how they relate and start poking around it like that. I quite like this one just because it's nice, visually appealing. Everyone's like, oh, wow, that's cool. But graph analysis is also really useful. It lets you answer different questions that relational doesn't always do so easily. So you can say, here's the customer, where do they live? What kind of car did they buy? Dig into that. Who else bought a Mazda? Well, where do they live? And then you can start relating, well, people who live in this place start to buy that type of car and all that kind of cool stuff. So this is the kind of stuff you can do with Kafka Connect. Configuration file saying, stream the data in from a database. Another configuration file, stream the data from this topic over to Elasticsearch, or stream the data over to Neo4j. Use the data wherever you want to do the particular job at hand. So Kafka Connect pulls the data from the source system, and Kafka Connect pushes the data down to the target system. So the demo worked, which is always nice. It doesn't always, but it did today. So I walked through setting that up. So when you're using Kafka Connect, there are a few little speed bumps, shall we say, along the way. So in England, we call them sleeping policemen. Do you call them out over here? They're kind of like those bumps in the road that the car goes, yeah, the same? Okay. So Kafka Connect is fantastic. Kafka Connect is what you should be using most of the time when you're doing integration. But there are a few of these little sleeping policemen, these little speed bumps, that when you start using it, you might come against. And that's why I wrote this talk. Because Kafka Connect's so important and so useful, but it can be a bit of a pain sometimes to understand what's going on. So I've shown you like the happy path, the perfect path, like, oh, isn't that simple? But now I want to explain some of the bits under the covers that when you are using it, you can understand some of the things you might come against. So Kafka Connect is, in a sense, for data engineers. It abstracts away this idea of having to write scary code. It's just configuration, which makes people like me happy because I can use it. But understanding what's happening under the covers is useful because it lets you make more sense of how you're deploying it and how you're configuring it. So you've got your source system, you've got your Kafka Connect box in the middle, and then your Kafka brokers. If you're dealing with a sink, it's reverse. You've got Kafka, Kafka Connect, and then your target system. I'll talk about how you actually deploy Kafka Connect later on. But an important point to kind of reiterate is that Kafka Connect does not run on your Kafka brokers. The only thing that runs on your Kafka brokers is your Kafka broker. Maybe Zookeeper, but a lot of people would disagree with that. So your Kafka brokers are for your Kafka brokering. Everything else, your streams applications, your Connect, your whatever, they run on separate hardware, container, /pod, /whatever. So within Kafka Connect, it breaks down into pieces. The first bit is the connector plugin. And the terminology gets a bit confusing because you've got Kafka Connect, and you've got connectors, and you've got configuration, and we've got converters as well. And I'm English, and I find it confusing. So the connector is the only technology-specific piece of the puzzle. So this defines how it integrates with the particular technology. So pulling from a database, that connector jar understands how to talk JDBC, or how to read a bin log, or whatever. If you're pushing down to Elasticsearch, it understands the Elasticsearch API. How do I take this piece of data and put it in this specific system? But after the connector plugin, it's then just abstracted through. So you specify the particular connector class that you want to use, and from that, the connector then passes internally. And this is under the covers. You don't actually really see this unless you're writing stuff. It's got a connect record, which is a generic representation of the payload plus the schema. And schemas is like this dirty word that some people don't like, but you kind of have to deal with it, because a lot of the time when you're pulling in data from a source system, it's got a schema. It comes from a relational database, it's got a schema. It comes from something else, it's almost always at least got a loose schema around it. So you've got this payload, and you've got the schema, and that gets passed internally as this generic representation. So from there on in, this is now just reusable components. So the first one, the next one that you have to use is the converter. So the converter deals with taking that generic Connect record and actually writing it to Kafka and converting it into and serializing it. So Kafka messages are just key value bytes. Okay? Kafka doesn't care if it's Avro or JSON or protobuf or who the hell knows what. It's just bytes. Whereas as users of Kafka, as developers with Kafka, you should be caring very, very deeply how you're serializing your data. Because there are good ways to serialize your data, and there are some really crappy ways to serialize your data. And a lot of the time, people go, eeny, meeny, miny, mo, that's the one I recognize, so I'll just use that. But actually, schemas matter. Schemas matter an awful lot. My colleague Gwen Shapira has this great quotation. She says, schemas are your contract, they're your API between your services. If you're using events to integrate between your services, which a lot of time you will be, schemas define that contract. And if you don't care about your schemas, or you're not loving and cherishing them and looking after them, things go badly wrong. But things go badly wrong 6 months later after you've already committed to like, well, that one looks easiest, we'll just use that. And then it's one of those, oh, bother. We should have maybe done something different. Now we have to kind of like backstep and unpick and do things the proper way. So if you're not using Kafka yet, then my strong recommendation is use something like Avro. If you're not sure, use Avro. If you're strongly opinionated, use something else, but at least know why you're using it, rather than like, oh, well, JSON sounds good enough. JSON itself doesn't have an innate representation of schema. So when you're passing these messages around, you have to have that schema somewhere else. You're emailing it to each other, you're checking it on GitHub, you're kind of like doing something bespoke and specific. If you use something like Avro, it has explicit support for schemas. So whether you're using Kafka Connect, whether you're writing your own Kafka producer, whether you're using something like KSQL, it serializes the data into Avro, which gives you a nice small little binary message that goes onto the Kafka topic, and the schema, which we need and know and love that we need, that schema goes into the schema registry. And the Avro message gets this little byte on the front of it with an identifier for the schema. Because then when we come to use that data, whether it's Kafka Connect as a sync, whether it's our own application with a Kafka consumer, whether it's KSQL or whatever, the deserializer says, oh, I'll read my Avro message, there's my little byte with the information, I'll go and fetch that schema, and now I can deserialize it. So schemas are super important. Schemas let you have this kind of quality control over your pipelines because you can actually stop putting crap onto the topic because the serializer will reject it or throw an exception or say, that doesn't match the schema of the other stuff. If you're just using JSON, you just have to cross your fingers as a consumer that other people upstream don't start mucking around. Because if they do, your stuff falls over. It's like, well, why the hell did that happen? And most solutions around that end up with some kind of human coupling around, I know, we'll have a change committee, and if you want to kind of change that, then we have to have sign-off process and all that kind of crap. If you use Avro or something like that, it actually enforces that governance of the schema on it. It says you cannot put something on that topic if it doesn't match the schema, if it's not compatible with the schema that you've declared. That's enough about schemas, but they matter an awful lot. If you're starting out with Kafka, if you're using Kafka and you're not giving a lot of thought to how do we manage our schemas, how are we serializing our data, please, please do so, because it will save you a lot of trouble later on. So, you've heard the Riot Act, you've understood that schemas are important, you've said, I know we'll use Avro for our data, or not. Screw that guy, we'll use JSON. Whatever you're going to use, you have to specify it in the configuration. So you can specify this globally, so your Kafka Connect workers, of which I'll talk about later, they can have like the default, and then when you're consuming from a particular topic, perhaps you're writing a sync, and someone else has written to that topic, they've been a naughty boy or girl, they've used JSON, you can override it and say, okay, this particular topic we have to read as JSON. So, connectors, technology-specific bit which pulls in the data from the specific source system or pushes it down to the specific target system. Converters, take our generic message from that connector, serialize it into Kafka, or on the sync side of things, take a binary, the bytes out of Kafka, deserialize it into a generic connect record. There's a third bit in the middle, transforms. So single message transforms are optional. You don't have to use them. But they're kind of useful. If you're building some kind of transformations, then in your pipeline, if you've got data coming in, you want to I want to mask this field, or I want to drop this field, or I want to rename the field, or I want to change the data type, or I want to change the topic name, or that kind of stuff, you can use single message transforms to do that. So it's only per single message. You can't start building aggregates. It's not designed for doing lookups to other systems. When you get into that level of transformation work, that's when you crack out Kafka Streams or KSQL or another stream processing library and say, right, now we need to do stream processing. Single message transforms are part of your pipeline, as it shows here. The data comes in, it passes through a transform, one or many or none, passes through the converter, and it goes into Kafka. So for example, you're pulling in data from a source system upstream. You've got a database, it's a HR database, it's got loads of sensitive information in. You pull in from the table, and HR say there is no way you're storing that chunk of the message in Kafka. Like, that cannot even hit Kafka. You can use single message transforms to say, well, we've got the full payload, we're going to drop all but X, Y, and Z. And then only those columns go through into Kafka. Or you can say, in Kafka topic, we've got this nice wide message. It's got a bunch of stuff in that's useful for lots of people consuming it. But we're now pushing this message down to a target system. And the target system, they only want a handful of fields. They don't want all of that stuff. So we could make them do the work and take the message and then process it. Or we could simply say, on the sync side of things, as it passes through in reverse, before we write it down to the target, drop out these particular fields or mask these fields, and then just push those other ones down. So it's actually a very, very lightweight but very elegant way of managing particular fields within your data. To configure them, it's not particularly pretty. I'll be the first to admit it's not pretty. But you simply prefix your configuration with the transforms prefix. You label each of your transforms. So you've got two different transforms. You've got label foobar and one called add date topic, which is a much more sensible name. And then each of the transforms have got configuration. So you've got transforms.label, and then it's got a type. So in this case, it's a timestamp router. The timestamp router's got configuration. It's got the topic format and the timestamp format. So we're going to take the topic. We're going to append the timestamp to it. So when we're streaming data down to Elasticsearch, for example, the Elasticsearch index will take the particular timestamp. So then we can do timestamp-based partitioning. This one here, label foobar, it's got a silly name. The type is called replace field, which is going to rename delivery address to shipping address. It's those little changes to the data which you can then normalize down your schemas. You can say, our business terminology is it should be called this. The source system called it that. We could say, well, just bring in the source system copy, and anyone who uses it then needs to remember to switch them over. Or we'll write a new application that will consume it and switch it over and write it back to a new topic. Or you could say, well, at point of ingest, we'll just fix that, and then we've got the actual corrected record stored in Kafka. So all of this is extensible. So I can't, but I'm sure all of you can. You could crack open the API and you could write your own connector. You could write your own transforms. You can write your own converter, and people do. So there's a huge number of existing connectors and transforms and converters. You can go and get them off Confluent Hub. You can find them on GitHub. You can find them all over the interwebs. But if there isn't a particular technology already written for, you can go and write your own. But the brilliant thing about it is all you have to do, if it's a source, is say, how do I pull a record from this funky database and then expose it? And Kafka Connect does all the rest. Kafka Connect can apply transforms. Kafka Connect will serialize it. Kafka Connect will write it to Kafka. Kafka Connect will handle failures. Kafka Connect will do all of it, except for that little interface between Kafka Connect and that source system. Or inverted, Kafka Connect and your target system, writing down to a target system. So that's how you go about configuring it. And it's important to understand some of those things. I lectured you at length about schemas and converters because they matter so much. Probably the biggest problem I see people having with Kafka Connect is going to Google, going to Stack Overflow, finding some configuration, running it, and it's like, yeah, I've got data in a Kafka topic because I pulled it in from here. And then they find another one, and they write it like, I'm going to take data from this Kafka topic to push down to there. Why is it not working? It's like, well, you're trying to get a round shape through a square hole because you pulled it in Avro and you're trying to write it out as JSON. It's like you can't just pick and choose like that. You have to be conscious and think about how am I going to serialize my data. Once you've configured your connectors, you can then start deploying them and running them. So like I said, Kafka Connect runs on its own instance / bare metal / container / pod / whatever. But before we even get to that, we have to understand logically how does it run. So when you create a connector, so we've got our S3 sync connector, a connector will run, connector is our logical definition, and it will run using one or more tasks. So if we're writing to S3, maybe we only have a single task because we can't parallelize it. If we've got a connector pulling in data from a database, maybe we've got a single connector, maybe we're pulling in multiple tables. So actually, why don't we just pull from those tables concurrently? So we can have multiple different tasks. And this is something that's specific to each connector. The person who wrote that connector will have said, does it make sense to parallelize this work? If someone says do a select star from every single table in the database, technically, could I parallelize that? Yes. Will my DBA hate me? Probably, but that's up to the user to configure. So you can configure that each way. So Kafka Connect will scale out the work if you let it. And those tasks execute within workers. So now we get down to the nitty-gritty. Our workers are our actual JVM processes. When we start going to actually run it, and where's this thing actually reside, it's a JVM process called Kafka Connect. Within that JVM process, you've got your different tasks being executed. But it doesn't stop there. Kafka Connect, just to confuse you, and I have to say it does feel slightly like this, has two different deployment modes. So, first speed bump, first sleeping policeman to watch out for is how am I serializing my data, how am I deserializing my data? Second one to watch out for, how am I running Kafka Connect? Because there are two modes. There's standalone and there's distributed. And it's like, well, which one do I pick? And most people say, well, I'm just starting out with Kafka Connect, I'm just got like a little laptop. Standalone sounds safer. Distributed sounds like big and scary, like hack and use, like web scale, which maybe I'll get to eventually, but I'll just start off with standalone because that's much more standalone and simple. Unfortunately, that's not the best choice. The best choice almost always is to go for distributed because distributed runs on a single node. The point of it is that it can be run distributed. Whereas when you run standalone, it's just a standalone worker. The offsets, like where your connectors have got to, it stores in a flat file. Its configuration is stored in a flat file. If you need to scale it out, so you've got a JDBC connector pulling in data from a database, you've got an S3 connector pushing data to S3. If you reach the capacity of a single machine, you can't scale it out other than kind of a scale out, which is to deploy two workers, a connector on each. So now we've scaled it out. But let's say our company it's growing. They say, well, we can't fit it all on a single machine, so we need a bit more capacity. We've kind of saturated the CPU on that one. We need more capacity. So we scale it out. Now we have two JVMs, one with a connector on each. Our company gets bigger and bigger, and we have more and more work on the database. We're ingesting so much, we can't keep up with the throughput, saturated the network throughput. Now we've got nowhere to go because it's a standalone deployment. You can only have a single JVM for a connector. A connector cannot be deployed over multiple ones in standalone mode. The other problem with this is it's not fault tolerant. If that machine goes bang, or that pod, or whatever it is we're running it on, if that goes bang, we've lost it. We have to hope that we've persisted that offsets file somewhere, because that's important runtime information, that's state, that we'll have lost. So it's not fault tolerant. This is where distributed mode comes in. Because distributed, it's exactly the same. It's a JVM process, the tasks run within it. But the offsets, the configuration, the status of the tasks, they all get persisted in Kafka itself. So do you remember right at the beginning, I was talking about Kafka and Kafka persists data, and not everyone realizes that. Kafka can persist data forever. So Kafka has something called compacted topics, where it's guaranteed to always have available the latest value for every single key, regardless of when that message was written. Could have been 10 years ago, 1,000 years ago, infinite years ago. It always keeps the latest value for every key. So Kafka Connect actually uses Kafka itself as its only store of state. It's pretty clever, because Kafka itself is a distributed system, it's fault tolerant, it's resilient, and so on and so on and so on. We can rely on Kafka storing that data for us safely. Kafka Connect does that. So it means that we can then scale it out. We can say, we'll add another worker. We need more capacity. Kafka Connect says, oh, hey, we've got a second worker. It will form a cluster, and we simply do that by saying it's on the same cluster ID, and it just does it. But we don't have to start copying around files and saying, oh, where's that status file, that offset file? Because it's using Kafka. So it's a distributed system built on top of a distributed system. And it's also fault tolerant. So that worker goes bang, Kafka Connect says, well, that's fine. I'll just run the workload on the remaining workers. And we can scale out and go in and out as we want to. Kafka Connect manages that for us. Kafka Connect, in distributed mode, we can also still partition. We can also still have independent workers for different connectors. So it's starting to get a little bit confusing here, but you don't have to have one great big cluster. So don't take away this idea that Kafka Connect, if in distributed mode, means my company has like 1,000 node Kafka Connect cluster and everything runs in it. You could do that, some people do that, but a lot of the time people deploy it with separate Kafka Connect clusters per connector type or per team function or per whatever. So you've got the distributed nature of it, you've got the resilient nature of it, you've also got the workload isolation of it. In Kafka prior to 2.3, there was this thing called the rebalancing. So if a task changed or a worker went bang or something like that, it did basically like stop the world rebalancing. So if you've read about Kafka Connect, you may have come across this. In Kafka 2.3, that's no longer a problem. So you can actually have bigger clusters and worry less about the impact of that rebalancing. For deploying Kafka Connect, you can run a container if you want. There are Connect images on Docker Hub. If you want to create your own image, all you need is that particular plugin jar to drop into your image. So the plugin jar you get off Confluent Hub, and you can install it either at runtime, so using something like Docker Compose to pull that down and then launch the worker, or you can just build your own Docker file from that and store it in your own repository. You can also automate the creation of a connector itself. So that's talking about building an image, but once you've spun that up, you've just got a Connect worker with no configuration. You can automate that's the creation of that configuration. So you launch the worker, you wait for the worker to spin up and start running and the REST API to be available, and then you just say, here's a lump of JSON, and go and create it. Troubleshooting. I could lie and say that there's no need for this because it's all simple. But I've already alluded to the fact that it's not always happiness and roses. So sometimes with Kafka Connect, you do need to start doing a bit of debugging. And Kafka Connect, again, it likes to mess with you a little bit. So the first thing you'll do, you'll say to Kafka Connect, which connectors have I got? And what's their status? And it'll say, well, you've got a connector and it's running. And you'll say, yes, my connector is running. Where the hell's my data? Why have I got no data? And Kafka Connect says, well, the connector's running. Your tasks aren't. Your tasks are screwed, but the connector's running. And that's to do with the nature of your connector is your logical entity. The work is carried out by one or more tasks underneath. So as Kafka Connect sees it, a worker can be created and running, but the tasks, one or more, may be failed. So the aggregate of those tasks being failed is nothing happens. So you always have to look at the status of both. You can use the REST API to get a stack trace out of tasks that have failed and start poking around that if you want. It's usually quite useful, but almost always what you'll need to do is dive down into the Connect worker log to actually work out what's going on, what's failed, what caused the task to abort. Kafka Connect does have some error handling built in. This is improved in recent releases. So it actually has the ability to skip over bad messages, and it has the ability to send messages to a dead letter queue. This is definitely the message you will see if you take the approach of Stack Overflow and random jiggling it until things work. And you'll randomly jiggle and then things won't work and you'll hit up against this, which is when you try to use the when you try to use the Avro converter to read data that is not Avro. Because do you remember I said when I was talking about schemas, you get this little magic byte at the front of the Kafka message which describes the schema itself. the Avro converter tries to read a message that's not Avro, it's like, oh, I can't read that. So if you have a topic with JSON data in, and you say to Kafka Connect, use the Avro converter, Kafka Connect will say, huh? That's not Avro, and it'll throw that error message. You'll also get that message if you've got a topic with both. And this is what you get when you're doing the random jiggling of, I'll try this out, I'll try this out, I'll try that out, oh crap, it's broken. Because you'll have bits of JSON, bits of Avro, bits of who knows what, and your connector will say, well, I'm going to try and deserialize it using the one I've been told to, and as soon as it hits one that it can't make sense of, it'll fall over, which is where the error handling comes in and the dead letter queues. So by default, Kafka Connect will fail fast, which sounds good, but it means it'll fall over and cry. Because it'll say, well, I can deserialize those first two messages. That third one, I don't know what it is. So it'll write the first two down to the target sink, and then it'll abort. And you have to go along and pick up the pieces, which might be what you want to do. It might be you're writing down to a target system that cannot have missing data. It cannot have corrupt data. We would much rather stop processing than send anything down that we shouldn't. It could be, though, it's like, well, can you just send me some damn data? I don't mind if you miss some of the bad data, just send me damn data. So in that case, you can say, well, set the errors tolerance to all. If it can't deserialize it, that's OK, it keeps on going. And you can also say, if you hit a message that you can't process, go and send it to another topic. So that way you get all of your good messages down to your sink as they should be. You get your bad messages written to a topic, which is just a Kafka topic. So you could go and inspect it using something like Kafka Cat. But let's say you've got a source topic that's been written to by different systems. It's supposed to be Avro data, but you've got someone didn't get the memo. They're writing valid data, but in JSON. You can use this pattern to actually say, well, we'll consume Avro data. We'll not fall over if we hit any JSON. We'll write it to a new topic, dead letter queue topic. And then we can consume from that topic using a JSON converter and assume it's JSON and try and read it that way. So you get kind of like two passes at the same data without dropping any data. To monitor what's going on, you've got the REST API, which is what I showed you in the demo. So you can basically just iterate through the connectors that exist and look at their status. You can also use Confluent Control Center to look at the throughput that you've got, to look at the lag over the different consumers, the connector tasks. And there's also JMX metrics. So you can start to kind of like really dig down into things as much as you want to. So I hope that's been useful. I hope that's opened your eyes as to what Kafka can do in terms of integration capabilities. I hope next time you try to do integration, you won't just try and write it yourself. You'll at least think of Kafka Connect. If you want to try out Kafka and you haven't already, Confluent do have a managed, hosted Kafka solution with KSQL, with Schema Registry, managed for you in the cloud. So you can go along there, you can give that a try. So with that, thank you very much for your time. I think I've got 2 minutes for questions, if I may. Before that, I have a question for you, which is, may I do a speaker selfie with you? Because I like to collect these, and sometimes they turn out all right. So if you want to look like you had fun and it was interesting, I'll not take a picture of the screen. I'll take a picture of you lovely people. Thank you very much. So, any questions? One, yeah. What do you suggest to aggregate? You said it was not a good thing to aggregate data. Yeah. What would you suggest? So the question is, what would you use to aggregate data? Because I said don't use the single message transforms. I would recommend something called KSQL, which is a SQL language that you can use for stream processing. So you could actually, just as you would write an aggregate statement in a database, you can write the same SQL, but it will run as a continuous application. I can share you some links afterwards which show that. If you want to get down into it, the Java libraries, there's Kafka Streams. There's other stream processing languages as well, but I would start off with KSQL. Okay. Has anyone tried KSQL, by the way? Oh, that's my talk for next year then. KSQL is really good. Any other questions? Okay, thank you very much.